Hello everyone, welcome to this lecture on power electronics. In this course, we'll explore the fundamentals and application of power electronics. This is one of the most important field in electrical engineering. So in this session, we'll cover that four key areas: introduction about the power electronics and application of the power electronics, advantage and disadvantage of power electronics. The power electronics is everywhere around us, where we charge our mobile phone, when we use a laptop adapter, in electric vehicles, in renewable energy like solar inverters, and even in high voltage transmission systems. Without power electronics, efficient and the smart use of electricity would not be possible. Now let's start with the introduction to power electronics. Power electronics is a branch of electrical engineering that deals with the conversion, control, and conditioning of electric power using semiconductor devices. This means that instead of handling signal like normal electronics, here we are dealing with a large amount of energy flow. So it acts as a bridge between electrical energy sources and electrical loads, which helps us to use power more efficiently. As an example, the AC supply from the grid is not always suitable directly for devices like laptop, LED lights, or electric vehicles. Power electronics makes this conversion possible, and it combines that power with electronics. So, which is the energy handling capacity with electronics, which provides precise control and the fast switching. Then the main function of power electronics is to convert and control electrical power in efficient, reliable, and compact way. So this is the reason why today's systems are much smaller, lighter, and more efficient compared to older electrical equipments. Okay, now let's look at the basic control structure of power electronic systems. It starts with a source. This can be AC, DC. It is coming from the grid, renewable energy sources like solar and wind, or even it can be batteries. So, this power from the source is then processed by power converters. So these converters would be a rectifier that convert AC to DC, a chopper that convert DC to DC, an inverter that is DC to AC, or and cycloconverter, so that is AC to AC. The role of the converter is to change the form of electrical energy into the type required by the load. So that may be motors, that may be drivers, or that may be HVDC lines, EV lighting, heating, etc. Now to make sure everything works efficiently, so for work efficiently, we have a control circuit. So that this is the control circuit. We have a control circuit. So these include sensors, that PWM technique, microcontroller, and feedback system. So its job is to consistently monitor the output and adjust the converter so that the load gets correct voltage, current, and frequency. So finally, there is a reference signal. This reference signal, which represents the desired output condition. The control circuit compares this reference with the actual output and makes correction through feedback. Okay, let's see use of power electronics in the real world. So its scope is extremely vast, covering almost every modern technology around us. If we talk about the power supplies, we all use device like computers, TV, mobile chargers. They rely on switch mode power supply, that SMPS, for different for efficient and the compact power conversion. So in hospital, industries, and even in the data center, uninterrupted power supply, that UPS, ensure that continuous operation during power failure. So even the battery chargers in our mobiles, then laptop and electric vehicles are based on power electronic circuits. So in the industrial applications, motor drives are used for speed and torque control of DC, AC, and BLDC motors. Induction heating, melting, and the welding process are powered by converters. Then lighting control such as LED drivers and electronics ballasts. Modern factories also depend heavily on power electronics for precise motion and control. Now, if we talk about that renewable energy systems, where in solar power plants, inverters are used to convert DC from PV panels into AC for grid connection. And the wind turbines used converters and the controls for variable speed operation. Then fuel cell and microgrids rely on converters for stable power supply and distribution. So these makes power electronics the backbone of clean and sustainable energy. Now, if we talk about the transportation, so in transportation like electric vehicles and hybrid vehicles cannot exist without power converters. So battery charging, motor drives and control. In railways, the metros and trams, traction systems use power electronics for propulsion. Even aircraft and ships rely on power electronic supply systems for safe and efficient operation. Now for that HVDC, in case of that HVDC and facts, like for long distance bulk power transfer, high voltage DC, that HVDC transmission is used, which requires sophisticated power electronics converters. Then if we talk about the fax devices like SBC, STATCOM, TCS, UPFC, so helps in grid stability, voltage regulation and power flow control. These improves efficiency and reliability of our power system with the help of power electronics. If we talk about that military and space, so that satellites and the say spacecraft need power conditioning system for their um, electronics. Then the radar and the communication system depends on stable power supplies. Then electric propulsion system in space mission are also made possible by advanced power electronics. Now, if we talk about that medical application like high voltage power supply for X-ray machines, MRI, CT scanners are based on power electronics. Then laser surgery equipment use precise converters for controlled energy. Medical devices like pacemakers with wireless charging rely on miniaturized power converters. These are the vast application of power electronics. So we can say power electronics is everywhere in our homes, industry, hospital, transportation, renewable energy, space and defense. So it is truly the technology that drives the modern world efficiently and sustainably. Okay, let's move to the next slide. So here we'll see the advantage of power electronics. So it has high efficiency. Like modern power electronics switches like MOSFETs, IGBT operates with very low conduction and switching losses. So this means we can convert and control power with minimum energy wastage, making the system highly efficient, compact and lightweight. The power electronics converters are much smaller and lighter compared to conventional electromechanical systems. For example, a modern mobile charger is exactly compact because of power electronics, like unlike bulky transformer used earlier. So then other advantages like precise control. So power electronics allows accurate control of voltage, current, frequency and power factor. So this is very useful in applications like motor drives, renewable energy systems and industrial automation. And the wide range of applications, power electronics is used in domestic applications like industries, renewable energy, electric vehicles, medical equipments, HVDC systems and even aerospace. So in short, it touches almost every sector of modern life. Then the fast dynamic response, so semiconductor switch like MOSFET, IGBT etc can turn on and turn off very quickly. Fast switching make the systems highly responsive to change in load or operating condition. Then the integration with digital control, power electronics can easily interface with microcontrollers, then DSPs and microprocessor. So these allows advanced features like automation, smart control and IoT based energy systems. Environment friendly, so it's power electronics plays a major role in renewable energy integration like solar, wind, fuel cell. So it helps in energy savings and reducing carbon emission, making it a key technology for sustainable future. So these are the vast huge advantage of power electronics. So every technology has limitations and it is important to know them for practical applications like harmonic generation. Power electronic device, especially converters, produce harmonics. These harmonics can cause power quality problems, excessive heating, and even interference in communication lines. For example, in an industrial plant, harmonics can disturb sensitive instruments and reduce efficiency. Then the electromagnetic interference, the TMI. So that since power electronic device switch on and off very rapidly, they generate electromagnetic interference. So these EMI can affect nearby sensitive electronic equipment like medical devices or communication systems. Therefore, filtering and shielding are often required. And the limited overload capacity. Unlike mechanical devices like relays or contactors, semiconductor device cannot handle overloads, so they are very sensitive to overcurrent or overvoltage. Even a small surge in current or voltage can damage them permanently. The complex protection requirements means power electronic systems need extra protection circuit against overvoltage, current, and short circuits. So these increase the complexity and cost of the system. Then the poor power factor. Say that in some cases, converters like rectifiers draw non-sinusoidal currents, so which leads to a low power factor. So a poor power factor means inefficient utilization of electrical power and higher electricity costs. So that's why power factor correction is often necessary in such systems. So while power electronics has many advantages, it also faces challenges such as harmonics, EMI, limited overload capacity, complex protection needs, and sometimes poor power factor. So engineers must carefully design filter protection systems and compensation circuits to overcome these drawbacks. Okay, so from this today's lecture, first lecture, we can conclude that power electronics is like the heart of modern electrical system. It makes energy conversion more efficient, but it demands careful design and protection. So in the upcoming lectures, we'll see the classification of semiconductor switches in the second lecture. Okay, thank you for watching this lecture.